Hello Year 8, welcome to the final lesson of this chapter, so using and understanding fractional indices. If you could please write the title and the date, underline them, and then have a go at the do now tasks on the board. Please pause the video as you do this. Right, good, brilliant. Just a recap for anyone who's maybe a little bit unsure. When you're trying to find the square root of a number, it means which number do you times by itself once to get it. So what we're doing here with the 25 is you're trying to find the square root of 25, which means which number do you multiply it by itself to get 25? Well, we know that 5 times 5 is 25, and therefore the square root of 25 is 5. So you should have 5, 4, 9, 13 and 15. And then here, for the second part, you're looking for the cube root. So you're looking for this on your calculator. And if we're trying to find the cube root of 27, it means which number do you times by itself twice to get 27? Well, we should know that 3 times 3 is 9, 9 times 3 is 27, and therefore the cube root of 27 is 3. So these are all of our cube roots. And then here, in less than 25 words, write a sentence explaining why squaring something is the inverse of square root, and also why cubing something is the inverse of the cube root. Well, a square root is a number that when you multiply that number by itself, like here, you get the original number. So we can see 5 times 5 is 25, and multiplying a number by itself is squaring. Okay, so here, for example, we know that 5 squared is 25, and therefore the square root of 25 must be 5. Okay, if you don't have a definition, you could pop that down now if you want to. Right, lovely. Our success criteria today, to recall how to calculate the square and cube roots of given integers. We've just done that, so well done. We can tick that one off. Silver is to be able to calculate using exponents. Remember, exponents means powers of a half, and then to calculate using exponents of a third, and in some cases a fourth as well. Okay, so first here is our hook question, which we'll come back to later. We're going to look at, can we decipher the football boot sizes of Marcus, Paul and Aaron that Ollie's sorting out based on these exponents, and we'll come back to that later. Okay, so first things first, fractional indices and their connections to roots explained. So if you are looking to find the answer to a value to a half, okay, that's actually equivalent to just square rooting that number, and that's why we just looked at that briefly already today. Okay, if you're trying to find the value of a number with an exponent of a third, that 3 at the bottom tells you you're trying to actually find the cube root of that number. And then when you're trying to find the answer to a value with an exponent of a quarter, again, that denominator tells you you're looking for the fourth root. And this fraction is quite important on what the numerator, and the denominator mean. The denominator actually tells you which root you're finding. That's perfect, that's easy. And the numerator, tells you the power you're using. Now, for all of the questions today, we're looking with a numerator of 1. So actually, you don't have to do anything, because we know anything to the power of 1 is just itself. The important bit is knowing what root you're looking for and what goes here. Okay. Now, if we were together, hopefully we will be soon, we'd go through these definitions together, we'd all say them out loud, but I'd like you to say them to yourself and then copy them down in your exercise book. Please pause the video as you do this. Right, good. So we'll go through an example. So here we're looking at trying to find the value of a number to the power of a half, and we know from the previous slide that when it's a power of a half, all you have to find is the square root. And the square root of 4 is 2, and we know that's true because 2 times 2 is 4. 2 squared is 4, okay? So 4 to the power of a half is 2. Then we're going to look at 9 to the power of a half. Now you should know again, the denominator is 2, so we're looking for the square root of 9. Which number do you times by itself once to get 9? The answer is 3. We can see there, 3 squared equals 9, and again that's why squaring is the inverse to square rooting. Right, please copy down those taught examples in your exercise book with the stages of working, and then calculate the following. Please show your working. It's so important, particularly to look back at things, to see how you've done them. Please pause the video as you do this. Good, excellent. So you should have the square root of 16, which is 4. So 100 to the power of a half means, well, what's the square root of 100? And it's 10. 49 to the power of a half means, what's the square root of 49? And it's 7. And then 36 to the power of a half means, what's the square root of 36? And it's 6. Right, now we're looking at this exponent's change now, so it's to a third. So now we're working with cubed root, because remember that denominator tells us which root we're using. So we're going to calculate 8 to the power of a third, so we have to find the cube root of 8, which is 2, and that's because 2 cubed, look, is equivalent to 2 times 2 times 2, which gets us 8. Then we've got 125 to the power of a third, which means we're looking for the cubed root of 125, which is 5, because 5 cubed is 125. Lovely. Right, please again, copy down those examples and then do the questions that have just appeared. Please pause the video as you do this. Right, excellent. So 27 to the power of a third means what's the cube root of 27? And it's 3, because 3 times 3 times 3 is 27. Then 1,000 to the power of a third means what's the cube root of 1,000? Well, it's 10, because 10 times 10 is 100, times 10 is 1,000. And C is one that students sometimes get wrong. What's the cube root of 1? Well, it's 1, and actually any root of 1 is 1, because it doesn't matter how many times you multiply 1 by itself, you get an answer of 1. And then what's the cube root of 64? It's 4, because 4 times 4 is 16, 16 times 4 is 64. Lovely. Right, here are some standard examples. I would like you to evaluate each of them. So what is the answer? A couple we've done in the practice questions, but it doesn't matter. And here you'll notice there are a few where there's an exponent of a quarter. So what you're looking for in your calculator is a button where you have an empty box and the root symbol, and you can then input your own 4, and it will tell you what the fourth root is of that value. Please pause the video as you do this. Good, brilliant. So these are what your answers should be. If you disagree with them, any of them, please let me know. Answers on a postcard, carrier pigeon, anything will do. Brilliant. Now, we're going to have a look at some investigative tasks now. So I would like you to read this one carefully and pause the video as you answer it. Right, good. So Annie and Mo are working out 27 to the power of a third. Annie says the answer is 9, and Mo says the answer is 3. Okay, so who is correct and how do you know? Well, you should know that Mo is correct, and Mo is correct because he knows that when it's something to the power of a third, what you're looking for is the cubed root, and 3 times 3 times 3 gets you 27. What mistake has Annie made though? Please pause the video and have a look and see if you can work it out. Right, good. The mistake Annie's made is she's done 27 divided by 3, because she's read that as what's a third of 27, and she's got 9. So the sum looks okay because it makes sense, but actually she's not trying to do 27 divided by 3, she's trying to find the cube root, and that there is a common misconception. So just keep an eye out, don't make those sorts of mistakes, please. Excellent. Next one, this is quite a challenge. So how has Whitney used the addition laws of indices to help us work out the power of a half? So she's working out 16 to the power of a half times 16 to the power of a half, and she writes this. Now we know she's right because the addition laws of indices say if you've got the same base value, which we have here, 16 and 16, and you've got exponents, indices, actually what you do is you add them. So she's done actually 16 to the power of a half plus a half gets you 16 to the power of 1. So if you multiply 16 to the power of half by itself, you get this. And we know that the square root of 16 is 4, and therefore 16 to the power of a half is 4, which is right because 4 times 4 would get you 16. Please, using Whitney's reasoning, can you find the values of these two integers? Please pause the video as you do this. Good, so here I'm hoping we've got 5, and here we've got 7, because you'd end up with 25 to the power of 1 if you do 2 lots, and 49 to the power of 1, and then the square root of those values is 5 and 7. Perfect. Right, this one here, take your time. So remember, it's bringing in our positive powers that we did a few lessons ago, our negative powers. Remember this idea of anything to the power of 0 and what that always equals and fractions. So put the following cards in descending order, so biggest to smallest. So maybe find out what the answers are first. In fact, I would encourage that you do that. Then put them in order. Please pause the video as you do this. Right, brilliant. So I went with the positive powers first. So 10 to the power of 3 is 1,000. 64 to the power of 1 is 64, and 10 to the power of 0 is 1. Then I went with my negatives, so I got 0.001, and then I went with my fractions, and I got 10 and 8 and 4 and 10. And then if I put them in descending order, the biggest is this one, followed by 64 to the power of 1, followed by 1,000 to the power of a third, and 100 to the power of a half. then 64 to the power of a half, because the square root of 64 is 8. Then the cubed root of 64 is 4. 10 to the power of 0 is 1. And then 10 to the power of negative 3 is 0.001. And that's something you would have looked at right at the beginning as a bit of a recap of this chapter. Right, now is our super challenge. So Dexter says he can represent 8 in 3 different ways. So 64 to the power of a half, so we know he's right because the square root of 64 is 8, so that represents 8. We know that this means 2 times 2 times 2, which is 8, and then we know that the cube root of 512 is also 8. He does the same again with a different number, and this is one of his cards. So think about what you maybe need to do with that first. What could the other cards be? Please pause the video as you come up with other cards to represent the same value that this card represents. Right, well done. So the first thing you should have done is find out what the cube root of 216 is, okay, and it's 6. So you now know you're making cards that would also equal 6. So we've got here, we've got 36 to the power of half, because we know, we know that the square root of 36 is 6. We've got 6 to the power of 1, because any number to the power of 1 is just itself. And then we've got the fourth root of 1296, which is also 6. And you may have others as well. Right, here's some more complex examples. So what we're going to look at now is calculating problems. So 8 to the power of a third times 4 to the power of a half. So 8 to the power of a third we now know means we're trying to find the cube root of 8, which will be 2, because 2 times 2 times 2 is 8. And then we're going to do the square root of 4, which is 2 again, because 2 times 2 is 4. So actually what you're doing, 8 to the power of a third times 4 to the power of a half, is just 2 times 2, which gets us 4. Now we're going to do this one, 81 to the power of half and 27 to the power of a third, and we're going to multiply them. So 81 to the power of a half means what's the square root of 81? Well, it's 9, and 27 to the power of a third means what's the cube root of 27? It's 3, and 9 times 3 is 27. Please pause the video and copy down these examples. Right, good, now we're going to have a slightly different example because it's not two fractions, it's a negative exponent and a fractional exponent. So we should know that 4 to the power of negative 1 is equivalent to 1 over 4 to the power of 1, which is just a quarter, which remember is equivalent to 0.25, okay? So let's just bear that in mind. And then we've got 64 to the power of a half is the square root of 64, which is 8. So you're doing a quarter times 8. So really you're just trying to find a quarter of 8, which is 2. If it was a third of something, you divide by 3. Or half of something, you know you can just divide by 2. Please copy down this example as well. It's really important you do. And have a go at these questions here. Please pause the video as you do this. Right, good. So we should have 4 times 3, which is 12. 6 times 4, which is 24. 1/5 times 100, so that just means a fifth of 100, and 100 divided by 5 is 20. And then a third times 9, so a third of 9 is 3. Right, let's have a look here. Our diagnostic questions. Circle the number that is equal to 49.5. So have a look, think about that first. I'm hoping you've got 7, because we know what we're actually having to do is we're having to find the square root of 49. So what number times by itself gets 49? It's 7. But then it says here, why are the other answers wrong, and what mistakes will be made to get those answers? Just pause the video, have a look, see if you can work it out. Right, good. So we can see probably here what the person has done who maybe gets this wrong answer. They've just halved it. 49.5. Half of 49 is 24.5. Come to this one here. They've just written that fraction there as a 0.5, and this one here they've clearly really struggled and just gone, do you know what, I'll just put it as a fraction under 1 because I'm not quite sure what to do. But these are all common misconceptions, and that's why we show them to you so you understand why they're wrong and what you should have done. Right, next one. Circle the number that is equal to 27 to the power of a third times 2 squared. Please pause the video as you work this out. Right, good. I'm hoping the first thing you did was you realised that here you had to find the cube root, okay, of 27. So something times something times something is 27. It's 3. So you should have 3 times 4, because 2 squared means 2 times 2, and they should get 12. And the issues here are they've just done 27 times 2 and got 54, and then done 2 times a third and somehow put 2/6. Okay, so they've times the numerator and the denominator by 2. And then here They've found a third of 27, which would be 9, and then just times it by 4 and got 36, but we know that's wrong. So again, it's important we understand these misconceptions, because actually particularly higher tier as well, you get lots of questions going forward that what mistake has so-and-so made. We've looked at some of those already today with Mo and Annie. You have to be able to explain the issue and what they should have done. Right, here is back to our hook question. If you could please now pause the video and have a go at working these out. Right, good. So we should know that what we should have done for Marcus is we're actually trying to find the cube root, okay, of 729. And I hope you got 9. And then for Paul, we're trying to find the cube root of 1,000, which is 10. And then here we should know we're trying to find the square root of 90.25, and we know that it's going to be between 9 and 10 because the square root of 81 is 9, the square root of 100 is 10, so it's 9.5. So if you're putting them in order, Paul's got the biggest feet, followed by Aaron, followed by Marcus. Right, we'll now do true or false. Please have a look at this. Is this correct? Well, it's false, because actually the numerator and the denominator, their descriptions are the wrong way round. It's so important we get that right initially. Right, are these true or false? Please pause the video and work out your answers. So we should have true, that's false, the answer is 6, and then that's also true. Right, is that correct? It is, it's true. Is that correct? It's not, it's false, because actually we know 9 to the power of -1 is equivalent to a ninth, and a ninth is definitely less than 9, which is the square root of 81. Bruno has 53 sweets. If he eats 1,331 to the power of a third, he would have 42 left. Please pause the video and work this out. Okay, we know that it's true, because here, look, you're looking for the cube root of 1331, which is 11, and 53, take away the 11 he eats, leaves him with 42. Right, brilliant. If you could now complete the worksheet allocated to the topic of work, have a go at the Hegarty tasks. Really, really well done. Some tough topics this week. You've done brilliantly. Well done, Year 8.